Recommender systems, they've become the invisible engine behind everything from Netflix movie suggestions to Amazon's customers also bought carousel. But these aren't mystical black boxes, they're rooted in decades of research on collaborative filtering and content-based recommendation. Today, I'll walk you through building your own movie recommendation engine in Google Colab, step by step, with real code you can run, customize, and deploy. Why recommender systems matter. Before Netflix made, because you watched Stranger Things, you might like dark, famous, early systems in the 1990s at sites like GroupLens pioneered user-based collaborative filtering. By comparing one user's ratings to another's, GroupLens could predict preferences. That approach won the 2010 Netflix prize, netting $1 million for a 10% error reduction. Fast forward to today, scalable matrix factorization, deep learning, and hybrid models blend classic algorithms with powerful new techniques. In this tutorial, we'll use the MovieLens 100K dataset, 100,000 real user ratings on 1/700 movies. Pre-process data with Pandas. Train a collaborative filtering model using the Surprise Library's SVD implementation. Evaluate accuracy with RMSE and test set predictions. Generate top-end movie recommendations for any user. No prior setup is needed beyond signing into Colab. I'll show you every cell from imports to prediction. How it works. At its core, SVD factorizes the user item rating matrix into low-rank user and movie latent factors. Each user and each movie become vectors in a shared feature space. Users close to a movie vector tend to rate it highly. Surprise handles all the heavy lifting. We'll split data into train and test sets, fit the SVD model, measure RMSE on held-out ratings, then call the trained model to list the top recommended movies for any given user ID. Why this matters for you? Once you understand and implement this pipeline, you can adapt it to any domain, books, music, products, even job postings. You'll know how to ingest and clean real-world rating data. Choose and tune an algorithm. Evaluate and iterate. Package recommendations for production. No sugarcoating, recommender systems can be brittle if your data is cold or sparse. But mastering the fundamentals gives you the power to diagnose and improve any deployment. Stick with me, and by the end of this video, you'll have a live Colab notebook ready to run, customize, and share. Let's dive in. We are using on Google Colab for do collaborative filtering with SVD. Our objective: build and evaluate a user-based collaborative filtering model using the MovieLens 100K dataset, demonstrating the full pipeline from data ingestion to live recommendations. Here key steps are: data acquisition. Download MovieLens 100K from GroupLens. Load ratings and movie titles into Pandas data frames. Exploratory data analysis. Inspect rating distributions, compute sparsity, and visualize top-rated movies. Modeling. Use the Surprise Library to define an SVD algorithm. Split data into 80/20 train/test sets. Fit the model and evaluate RMSE. Recommendation generation. Predict missing ratings for a target user. Sort predictions to output the top 10 recommended movies. Visualization and interpretation. Display recommendation list. Discuss common pitfalls, cold start, popularity bias. Then we do extend with content-based features or hybrid filtering. Deploy as a web service using Flask or Streamlit. Let's see the code while debugging. Prepare the environment. Purpose is to check the working directory, /content in Colab. Ensures we're operating in the default file location for Colab. Then we download the MovieLens dataset and unzip it. It avoids re-downloading if the folder already exists, ML100K. And do sanity check, confirms the data files like u.data, u.item are present. Loads the raw movie ratings. User underscore ID integer from 1 to 943. Item underscore ID integer from 1 to 1682. Rating from 1 to 5. Timestamp when it was rated. Then converts to a matrix format with users as rows, movies as columns, ratings as values. Fills missing ratings with 0, meaning unrated. After that, store the row/column indices, actual user and movie IDs, for labeling output later. Next converts the dense matrix to compressed sparse row, CSR, format. Saves memory and speeds up matrix operations. Then we performs truncated SVD. User matrix, users times 50 latent features. Sigma singular values, strength of features. VT movie matrix, 50 features times movies. Reconstructs an approximated rating matrix. Every value is now a predicted rating from the model. Then wraps the predicted matrix into a data frame for easy indexing by user/movie ID. And takes a user underscore ID, recommends top N movies they haven't rated. Next we retrieves all predicted ratings for that user. Removes movies they've already rated, no point in recommending those. And sorts remaining movies by predicted rating and selects top 10, then loads the actual movie titles to convert item underscore ID into readable names. Finally it return list of movie title, predicted score, for the top N.